Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is surface areas and volumes. This is the third video on this topic. In the earlier two videos, we discussed the basic concepts and the hot questions. The links of those videos are given in the description box. This particular video focuses on MCQ problems. These are examination oriented. So pay attention here students and be ready with pen and paper. In the first problem, a shuttlecock used in playing badminton consists of a combination of shapes. So the options are hemisphere and frustum of a cone, cone and sphere, and cylinder and sphere. Let us recollect the shape of a shuttle. We see that the bottom consists of a hemisphere. So, and what is the shape of the top surface? Top looks like a cone, but it is not a cone, it is cut in between. We are truncating the cone. So what is that shape of that called as? Let us recollect. If we take an inverted cone, if we cut it, and what is the balanced shape? Like a trapezium, it is called as a frustum of a cone. So the shape of the shuttlecock is hemisphere, the bottom, and the frustum of a cone. Correct option is A. The total surface area of a solid hemisphere is. So what is the surface area of a sphere? Surface area of a sphere we know as 4 pi r square. So the question looks like for a hemisphere it will be 2 pi r square total surface area, but that is not correct. Let us cut this sphere into two parts and the hemisphere looks like this. There are two hemispheres here. So now one additional, this dark green color surface is also exposed. So the total surface area will be the curved one and the circular one here. So the curved one is 2 pi r square and this particular circle type surface area is pi r square. So the total surface area for a solid hemisphere will be 3 pi r square. Correct option is D. The radius of wire is decreased to 1/3. If the volume remains same, length will become 4 times, 9 times, 16 times or 3 times. Now we have to put the volume same. So we will put the volume as pi r square h, the initial volume. Now the radius is decreased by 3 times. So it will become r by 3 and the new height is h. The volumes are same. Simplifying this will give h equal to 9. 9 times the small h. So it means the height will be 9 times. Correct option is B. The volumes of two spheres are in the ratio 8:27. Find the ratio of their surface areas. The volumes V1 by V2 for the two spheres is given as 8/27. It is given here. We know that volume is 4/3 pi r cube and for the bigger sphere we have assumed as 4/3 pi capital R cube. 4/3 pi will cancel numerator and denominator. We are left with r by r, the whole cube, and this we can write it as 2 cube and 3 cube. So we can write it as 2/3 the whole cube. Now cube is there on both sides, LHS and RHS, so this can be removed and r by r will be 2/3. Now we have got the ratio of radius, we can find the ratio of their surface areas. Surface area is proportional to r square or 4 pi r square by 4 pi capital R square. 4 pi will get cancelled. So S1 by S2 will be small r by r the whole square. We will substitute this value 2/3 here. So it will become 2/3 the whole square, which is 4/9. So the ratio of surface area will be 4/9 or 4:9. Option B is the correct answer. Two cubes each of volume 8 cm cube are joined end to end to form a solid. Find the surface area of the resulting cuboid. Let us take two cube here which we are joining adjacently like this. and let the edge of the cube or the side of the cube be A. So when we join together, the length will become 2A, the height will remain as A only, and the width also will remain as A only. So but what is the value of A? We are given that the volume, each volume of the cube is 8. So A cube is 8. So A will be 2 centimeter. So the length is now 2A, which is 4. Width is A, which is 2. Height is again A, which is 2. We know that the surface area of the cuboid, now it is a cuboid. When we join two cube, it becomes a cuboid. So it will be 2 into L into B plus B into H plus H into L. So we'll substitute these values. We'll get surface area as 40. So the correct option is B. The curved surface area of a right circular cone of base radius 8 cm and height 15 cm is. Here all we observe that all the options are given in pi, in terms of pi. So when we are doing the computation, we should not put pi as 22/7 or try to solve. We will keep the constant pi as it is in our computation. So we will see for a right circular cylinder cone, height is h, radius is r, and this L is called as the slant height. So, and we know that the curved surface area of a right circular cone is pi rl. So we need to get first the slant height. So through Pythagoras theorem we can get L as r square plus h square root, which is 8 square plus 15 square, 64 plus 225 is 289, square root of 289 is 17. So the slant height is 17. Now we know that the curved surface area is pi rl. So that is pi into r is 8 into L into 17. We'll keep pi as it is. 8 into 17 is 136. Balance is pi. 136 pi centimeter square is the answer. Correct option is A. The cost of painting a cubical box of side 3 meter at the rate of 2 per square meter is. So we need to first find the surface area of the cubical box. What is the surface area is given as 6A square. 6A square, and each side is 3. So 6 into 3 into 3 is 54. 54 square meter is the surface area of the cube. Now at the rate of 2 per square meter, what will be the cost? So 2 into 54 is 108. So the cost of painting will be rupees 108. Correct option is D. If the curved surface area of a right circular cylinder of height h and radius r is 1/3 of the total surface area, then we need to find the relation between h and r. Which one of this is correct? What is the curved surface area of a right circular cylinder? Curved surface area is 2 pi rh. And what is the total surface area? Total surface area is 2 pi rh plus the two circular terms on top and bottom of the cylinder. So it will be 2 pi r square. This is the curved surface part. This is the top and bottom part together. Both are circular region. So now curved surface area is 1/3. So 2 pi rh is 1/3 of the total surface area. It is given like that. If the curved surface is 1/3 of the total surface. So we have written curved surface area equal to 1/3 of the total surface area. Solving this, we get R as 2H. The correct option is B. Friends, with this we conclude this video. I request you to please subscribe my channel and give a thumbs up to this video. Thank you very much, friends.